differentiate y equals the secant of tangent of x. All right, so here we have a composite function. Okay, so what do we mean by that? Well, if we call f of x the outer function, which is the secant of x, and the inner function, in this case, is tangent of x, then what do you notice, right? If we take f dot g, remember order matters, of course, right? This would be f is the outer function, the secant of, but instead of putting x here, right, we replace that with the other function, right? So the secant of the tangent of x. Once again, order does matter. Okay, so how do we find then the derivative of this guy using the chain rule? Well, remember we take f prime, okay, evaluate it at g of x, but then we have to multiply that by g prime of x. Okay, so in this case, what do we got? Well, what is the derivative of secant of x? Okay, the derivative of secant of x is, let's just write on the side here, all right? So f prime of x, the derivative of secant is secant of x, tangent of x. And g prime, right, the derivative of tangent is secant squared of x, okay? A lot to keep track of here, right? So what's the first step then, right? Well, this is the chain rule. So we got to find f prime, which we know, right? So the derivative of secant is secant x tangent of x. But remember, we don't just write secant x tangent of x, right? We write secant evaluated, right? Evaluated at g of x. So the secant of tangent of x times the tangent of x. So that's this part right here, right? But then what do we have to multiply that by? The derivative of the inner function. The derivative of tangent is secant squared x. All right. And this is your derivative. It looks a little bit complicated, right? But remember, the tangent of x is the argument of the secant function here. Okay, so we have the secant of tangent of x times the tangent of x times secant squared of x.